Good afternoon and welcome back to the Nexperia Power Live event. We're live now on our packages channel and here with you for the next 2 hours to discuss a number of design and technology insights surrounding our latest package technologies. We're starting this session on our industry-leading copper clip surface mount package family, LFPAK. So this first discussion is scheduled for approximately 25 minutes. We'll begin with a short introduction and then follow on for open questions. So please do join in. Contributions are all anonymous, so please do ask any questions to our experts, but also feel free to share your own knowledge and experiences. Questions can be asked throughout the live session using the chat function in the bottom right of your screen. So kicking off this afternoon's live schedule is Chris Boyce, Senior Director, and Samir Ahmed, Senior Applications, both from our Power MOSFETs division here in the UK. So with that, I'll hand over to Chris.
Thank you very much, Kelly, and welcome everybody. It's my absolute pleasure to kick off this session on our packaging technology. With a look under the hood of our flagship products, our LFPAK family. Let me start by just talking a little bit about what LFPAK is all about. This is our premium package for our MOSFET family. And it's really characterized by two design features when you start to look inside and outside the package. Firstly, as you can see here, is the internal copper clip that sits on top of the silicon. So as you can probably see from the diagram, these are vertical devices. The current is flowing vertically through the device. So essentially what we have is the silicon chip sandwiched between two pieces of copper. There's a copper drain tab on the bottom, then the silicon, and then the copper clip sits on the top. And you can see that the copper clip covers the vast majority of the surface of the die. That makes for a much more efficient and powerful construction than a more traditional wire bonded packages. It allows the current to spread out. And what that copper clip does is enable this sandwich of silicon between two pieces of copper. That really is what gives the real performance of the device. So that's it has high performance in terms of a maximum current rating, in terms of low RDS on, in terms of low inductance, and in terms of excellent thermal performance. And interestingly, this is a technology that's been inside Nexperia now for quite some years. And it also, we see ourselves increasingly using copper clip style packages, not just in the LFPAK, but in our clip bond flat power packages in the rectifier family, and also in our latest CC pack for our GaN devices. And if you stay online a little bit longer this afternoon, there are some other sessions that will address those packages as well. The other key design feature of the LFPAK is the gull wing leads that protrude there from the bottom of the package. These are power packages. During their lifetime, they will heat up and cool down and heat up and cool down many, many times during their life. And that thermal stress that is induced during that cycling over time puts stress on the solder joints and the PCB pads. And these external leads have been designed to act like little shock absorbers to allow that stress to stay away from the solder joint itself. And what you end up with is a package with excellent board level reliability. So our LFPAK family are all qualified to the AEC Q101 automotive standard. And indeed, many of the devices are able to pass many times the requirement of that standard because of that excellent board level reliability. It also has some sundry benefits in terms of allowing for easier optical inspection, so you can check your solder joints more easily than a PQFN style package where the contact is right at the edge of the device. Although the LFPAK looks a little different from some other power packages on the market, from the very beginning, we designed it with the ambition to be footprint compatible with similar devices from other manufacturers. Over the years, we've built up a portfolio of material that confirms that, really in two respects. Firstly, we've taken the recommended footprints from all of our competitors and made sure that our LFPAK packages will sit on those footprints. So if you're currently using a device from somebody else, then you can switch to an LFPAK from a PCB perspective. But also, we've introduced this concept of universal footprints, both in the 5mm by 6mm sort of Power SO8 type devices, but also the 3x3 and more recently the 8x8. So if you design using this universal footprint, then not only is that footprint able to accept an LFPAK, it's also able to accept devices from other manufacturers. So really just trying to make the transition to using LFPAK as simple as possible. And that's we've done this not just from our own perspective, but we've had some independent consultancies look at this and write some reports and look at some of the detail around that, and those reports are available from us should you need them. The LFPAK is now a family of devices. It started out with the sort of 5x6 Power SO8 style device. But then over time, we've gone down in size to the LFPAK33. We've gone up in size to the LFPAK88, which we introduced over the last year or so. We also have some dual devices where we have two independent MOSFETs inside the same LFPAK56. And in the future, we'll have some half-bridge devices as well, both in the 5x6 and in the 8x8. So it started out as a single device, and as you'll see, it's grown. The portfolio has grown over the years to offer different packages for different power levels, but all fundamentally exhibiting the same internal construction as I showed on the slide earlier. I mentioned that the copper clip, one of the benefits of the copper clip is that it really allows us to have a high maximum current rating. And you can see this here across the different LFPAK package sizes, starting with the LFPAK33 at the bottom, which for a 3x3 device to be able to support 160 amps is pretty impressive. But if you take that right the way up to the 8x8, then we're in excess of 425 amps. I should stress these are, firstly, these are not calculated numbers. They are or theoretical numbers. They are numbers that we have tested in our lab to ensure that we can achieve them. And indeed, they're not pulse numbers. These are DC. These are DC numbers. So long as you can keep the device cool enough in your design, then we can support these current ratings on a continuous basis. And finally, just to give a little bit of the history. So actually, we started with the LFPAK, our very first LFPAK, way back in 2002, would you believe? And as you can see there from the bars on the sales graph, it was a pretty barren existence for LFPAK for the first few years. We were out there promoting this technology. At the time, copper clip technology was very new and very rare in the power transistor world, and so that was pretty tough time. When we get to sort of 2007, 2008, as people start to take the message on board and try a few designs, And you can see we get some early sales then in the late noughties and early 2010, 2011. And then from about that time, the word's out. People have started to use these devices for real in high volume applications. And as the saying goes, the proof of the pudding is in the eating, and they see the excellent reliability and the excellent performance that they're able to achieve. Since then, we've been on a massive growth curve as the packages have become more and more popular. We've expanded the portfolio, and they've really proven themselves in earnest in the real world. People have, in the automotive sector, they've been used under the hood in very harsh environments, and the failure rates have been really, really low, and that's encouraged a much wider adoption. So we're now at a point where you can really consider the LFPAK to be an industry standard. If you want a power package for those harshest of environments, then most often LFPAK is the place to go. That culminates in the fact that we have now shipped somewhere in excess of 7 billion devices of LFPAK, and we're shipping more than 1 billion a year, and have been for the last couple of years. And that brings its own challenges. It's easy to perhaps build small numbers, but to build them reliably, cost effectively in that kind of scale takes some particular skills, and something that Nexperia is very good at. As a company, we build 90 billion devices a year. You have to have your manufacturing, your quality really well under control to be able to do that reliably. That's a real skill that Nexperia brings to the party, and indeed has brought to the LFPAK family. So I'll shut up now. Turn this away from being a sales pitch, but much more an interactive session. I'm kind of hoping that some of the people online, we have some people who are both users of LFPAK today, and also perhaps some people who are new to the device. But I'd love to answer any questions that you might have.
Super, thanks, Chris. Okay, so we'll open the floor for questions now. Just to remind you, if you have a question to ask, you can do so using the chat function at the bottom of your screen. The first question in, Chris, the internal design is copper clip, but are the outside pins also copper or in different materials?
So they are, in fact, I don't know if you just come back to the diagram where you can kind of see it. You can't really see it from this diagram so well. Let me just get my mouse here. This source clip, so the bit that covers the die here and then bends up here and then indeed comes out on these legs, is a single piece of copper. And that is laid down on top of the silicon. There's some solder, and then the whole thing is laid down. The external bit is silver because it's been plated to enable good solder adhesion, but that is in fact a single piece of copper. And so yes, it's all copper. It's just on the outside it's been plated.
Okay, thank you. The next question is, what is the thickness of the copper clip and also the copper pad for die attach?
Ooh, I don't have those numbers specifically in hand. We can certainly follow up with that if that's of relevance. What I would say is that it's been it's not a number that we just happen to use because that was the convenient thickness of gauge of copper that was available. Quite a lot of effort has been put into several design aspects around this. So from the drain tab perspective, we need a nice, good thermal base there to help get the heat out. So we use a a particular gauge of copper for the drain tab, and then the important thing about the gauge of the copper on the clip itself is to make sure that this construction here, where we bend these legs, and the radiuses that we use, and the position of the bends, and the thickness of the material, all go into making up the excellent board level reliability. I mentioned that these things need to act like mini shock absorbers to compensate for the different levels of expansion between a PCB and the package itself when these things heat up and cool down. So we've chosen that that gauge very carefully, such that that we get the right spring effect in here. If it's too thick, then too much of the stress is transferred. If it's too thin, things can become flimsy, and also it starts to reduce the current rating or increase the RDS because we don't have as much copper in the path as possible. So it's a carefully designed piece of engineering to give the overall package capability its overall performance. But I don't know the numbers directly off my head, but obviously there's nothing secret about that. We can follow that up and perhaps publish that in the Q&A, Kelly.
Sure, no problem. I'll make note of that. Okay, next question. Are all the LFPAKs wave solderable?
Sammy, do you want to pick that one up?
Yes, they are, in a short answer. So
I think the 33 you have to be a bit careful with, because the leads on that size of thing, it's quite, it's a little bit touch and go, but certainly the 56 and the 88 are, yes.
Okay, and on to the next question. Any plan to keep enlarging the footprint, for example, 10 by 10 or 12 by 12?
Very, very interesting question. So under review is the honest answer. This is a core part of our capability. As you've seen in the presentation, we've continued to expand the portfolio over time, and we're certainly not done. We've got some ideas for some other devices that utilize the same construction. How big do we need to go? How big, to what extent does it make more sense to have multiple devices versus a single device in different applications? That's all up for discussion. But no, that is certainly something that we are considering doing an even bigger version. And I don't know who asked the question. Obviously, it's all anonymous. But if you have a particular requirement or particular interest, please make contact with us, and we can try to understand your requirements and build that into our thinking.
Sure. Thank you, Chris. The next question: have you tested board level reliability of the LFPAK 8x8 package mounted on insulated metal substrate?
So that again is in progress as it stands. So we have done the LFPAK88 on FR4. And I'm pleased to report that it exhibits excellent board level reliability. Again, the selection of the construction of those external leads. We have built up quite some knowledge in that area over the years, and the LFPAK88 is really performing very well from a board level reliability perspective. But that's on regular PCB material. We're in the process of getting some work done on IMS to prove the capability on that as well.
Okay, on to the next question. I'll wrap two questions together here, actually. What is the availability of the dual FET in LFPAK88, and will it be intended for automotive?
So I'll answer those in reverse order. So the first and the second question, the answer to the second question is absolutely yes. It will be an automotive product. In fact, the very Nearly all of our LFPAK devices are automotive qualified. There's one or two very small exceptions where it doesn't, they're not really designed for that space. In terms of timing, it will be, we'll have samples during the course of next year, during the course of 2021.
Okay. What is the reason for keeping 3 pins of source as they are internally connected to one copper clip?
Sammy, you want to pick that up?
Yes, I can take that one. So it's in relation to the board level reliability. That's one aspect. The 3 pins do give you this flexibility of bending due to the thermal cycling. And it doesn't take away anything from the capability in terms of current, because part of our rating, we do consider the capability of the copper. There are 3 pins, and they are connected all into one piece internally. The other thing that the advantage that this gives as well is the reduction in the inductances, the package inductances. So each pin, because they're pretty much in parallel, then that helps reduce the parasitic inductances.
Okay, super. Thanks, Sammy. What is the difference for the secondary variant of LFPAK86 in E? I think they mean the LFPAK56E there.
Okay, so we're talking about this device here. So the first device that we ever produced in LFPAK was this LFPAK56, this device here. That was, it was our first experience in this, and we were a little conservative with some of our design rules in terms of the size of the piece of silicon that we could put inside. Obviously, from a MOSFET manufacturing perspective, the more silicon that you can squeeze into your package, then you have the ability to offer a lower RDS(on) device. The bigger the piece of silicon, the more parallel paths there are through the silicon chip, and therefore the lower the RDS(on) that you can offer. As you can see from the LFPAK56E, we have extended the plastic up a little bit further, and what that allows us to do inside is to put a larger piece of silicon inside. So what you will find is that the very lowest RDS(on) devices that we offer in LFPAK56 or in a 5x6 package will make use of this package, whereas where we have a higher RDS(on) and we don't need to use every square millimeter inside the package, we'll use the kind of traditional device. So it just allows us to put a slightly bigger piece of silicon in there and to really offer the very lowest RDS(on) device that we can.
Thanks, Chris. Lots of questions about the half bridge. When are the half bridge products available, and how is this different to the dual MOSFET?
So let me just say, from an availability viewpoint, again, it's something that we will see start to appear during the course of next year, and I'll leave Sammy to explain some of the internal differences.
Okay, thanks, Chris. So the difference, the main difference between the two is that the H bridge has got an internal connection to make the actual H bridge between the low side and the high side, while the dual, the 2 separate MOSFETs. Now, what does the advantage of the H bridge is, of course, it's intended for applications such as a 3-phase brushless DC motor or DC-DC converters, where the H bridge is the 2 MOSFETs are configured in H bridge. The internal connection would allow for a bigger die, achieving lower RDS(on), as well as layout advantages compared to the dual. So that's purposely done, and these are the main advantages of the H bridge.
Perfect. Thank you, Sammy. So so we've run out of time for questions. We do actually have quite a few questions that we've not had the opportunity to answer. So we will collate those. We'll get the team to create some answers, and we'll publish a Q&A document after the event. We'll publish it underneath this video. So with that, thank you very much to Chris and Sammy, and thank you to everybody who sent in their questions.
Absolutely.
You can take a look below the video screen. You'll see links for further information on our LFPAK family of products. There's tons of information throughout the site. If you want to speak to somebody in more detail, you can use the chat function on this website as well. So if you've got more time this afternoon, hang around. We're taking a 5-minute break, and then we're back to discuss high current MOSFETs. Thank you.